So hello guys, today we are going to solve a Leetcode question that goes by the name find the pivot integer. It's Leetcode daily question. The question number is 2485 and it's an easy question, okay? It's an easy question, okay? So how we'll solve it? How we'll solve it? You know the flow. If you are just new to this channel, what we will do is we'll first try to read the problem statement and then we'll try to analyze what the question says and how we can think of how to arrive to the solution. We will not directly tell the solution, okay? I will not directly tell the solution because I have solved it on my own. So I'll just convey my thinking, okay? I will just convey my thinking, how I got to know this and how I move on to this, how I like proceeded further, so that you can think the same way, okay? So that you can just not cram the algorithm, because I don't know if the solution that I'm going to tell is in any of the books. I don't know that, okay? But if this intuition is coming to your mind, like if you can think of a solution, doesn't matter, okay, if there is any algorithm existing already that can solve the solution, okay, maybe your solution is better than yours, better than them, okay, who knows. So let us first try to we will first try to read the problem statement and then we will eventually arrive to the solution. Then we will eventually arrive to the solution, okay? So let us go to the first step, reading the problem statement. What is the problem statement? Given a positive integer n, find the pivot integer x such that the sum of all elements between 1 to x inclusively equals the sum of all the elements between x and n inclusively. Okay. So what it is given is the sum of all the elements between 1 and x inclusively equals the sum of all the elements between x and n inclusively. Okay. That means basically you are given some integer. You are given some integer. Okay. Suppose 8. Okay. So you have to find a point. You have to find a point between one. Basically, if this is on a number line, okay. Basically, if this is represented on a number line from 1 to 8, 1, 2, 3, 4, 5, 6, 7, and then 8. Okay, if this is represented on a number line, suppose this is my integer. So I am saying that the sum of this to this 1 to 4 and the sum from 4 to 8 should be equal. 4 to 8 should be equal. Remember, this is inclusive. So this array sum should be equal to this array sum. Should be equal to this array sum. Okay. This sum should be equal to this sum. Okay. That is what I am given with. That is what I am given with. Okay. Return the pivot integer x. Okay, return the pivot integer x. If no such integer exists, return -1. It is guaranteed that there will be at most one pivot index for the given input. Okay, so what the question, at most one, so 0 or 1, at most basically means less than equal to, okay, less than equal to a given value, suppose k. Okay, so this k in this case is 1, less than equal to 1, less than equal to 1. Okay, so what I have to find is basically, if I just don't number them, okay, if I just remove the numbering, I just know that there is 1 and there is 8. Okay, so this is some x, and I have to find this x such that the sum from 1 to x equals the sum from x to n. Basically, the sum from 1 to x inclusive equals to the sum from x to n, okay, from x to n. Okay, now we have got the solution. We have got the problem statement. What we have to do, this is what I have to do. I have to find some index. Such that the sum till here equals the sum from here to here. Okay, both are inclusive. Okay, so how can I think about this? Basically, suppose you are given a number 5. Okay, so from 1 to 5, you have to basically, what you have to do, suppose you are given from 1 to 5. So for finding a finding an integer x at the place such that this sum equals this sum equals this sum. Okay, so for getting this sum, basically this can be get if this is x, this is y, and this is z. Okay, so as you can see, x plus y equals to z, x plus y equals to z, or I can write it as x is equal to z minus y, y is equal to z minus x, y is equal to z minus x. I can write it like this. Okay, I can write it like this, z minus x. So basically, if I am given something like this, I am given something like this, I am given something like this. This is basically a number line, okay? And the numbers are from 1 to 8, and this is some x, okay? So this part can be found out by subtracting, this can be found out by subtracting. Basically, this can be found out by subtracting y from z. If I subtract this y from the z, what I'll get is I'll basically get this value that is equal to my x, so if I know the sum till this value, till this value, okay, I can basically iterate for all the values in between. I can basically iterate for all the values in between, and whenever I get to see that my x equals to z minus y, this condition is satisfied, then I'll say that that is the pivot index. That will be the pivot index. Okay, if I just try to tell you what I was trying to convey is, this is my array. I'm telling the same thing again. Okay, same thing. This x and this y composes z. This composes z, full z. Okay, so x plus y can be written as z, or it can be written as y is equal to z minus x, or I can simply write it as z x is equal to z minus y, basically shifting the y towards the right hand side. Okay, so I get this equation. So whenever this condition, basically this condition can be given, or I can say that whenever this condition is fulfilled, that my x is equal to z minus y, it means that the pivot index exists, and I can simply return that pivot index. So whenever this condition becomes true, I'll simply return the index. I will simply return the index. Okay, I'll simply return the index. Okay, and if this condition doesn't become true at any case, basically I'll traverse the whole array and this condition never becomes true. So I can simply say that I can simply return -1. That means there exists no pivot index for this case. No pivot index for this case. Okay, that was my overall solution. What we'll do is first, basically for getting this equation x plus y, okay, is equal to z. So I have to get this z. So I have to iterate the array once. And I'll have to add all the elements. So I'll have to add all the elements. That will be equal to my z. Okay. That will be equal to my z. Okay. That will be equal to my z. So okay. That will be equal to my z. Okay. That will be equal to my z. Okay. So what I can say is whenever, while just add, and after adding, I can just traverse, and whenever this x becomes equals to z minus y, I'll simply return. Whenever this condition is fulfilled, z minus y, x is equal to z minus y, I'll simply return the index. Or I'll return -1 if the condition is not satisfied. I'll return -1. Okay. So this is what I have to do. Basically, if I just take a test case and try to tell you how to do it, we'll take till 8. Okay, if this is the test case given, I will take till 8. Okay, 8 is my number given. So if I just try to put it on a number line, it becomes like 1, 2, 3, 4, 5, 6, 7, and then 8. Okay, so I can get the sum of all the elements. So if I try to get the sum of all the elements, it would be like 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8. Okay, so I would get it like this: 3, 6, 10, 15, 21, 29, 36. 29, just a second. 8 into 9 divided by 2, 36. Okay, this is what I did. What I did is basically n into n plus 1 by 2. I just applied this formula to get the sum of the first n elements. Okay, this gives us the sum of first n elements. So now I know the z value. Now I know the z value. Okay, now I know the z value. So what I can do is basically I'll just start traversing from here. I'll just make one more x. I'll just make one more x. Okay, I'll just make one more x. And what I have to do is, now what are the quantities that I know? What are the quantities that I know in this? As I'm traversing, I know the x. So this I know, this I know, this I know, this I know. Okay, this I know, this I know. Okay, so I have to just make this condition that z minus, basically what I have to make is, as I know both of these, I can simply do like this. What I can do is, uh, okay. What I can do is, while I'm traversing, I'll just subtract the sum. That is gotten till now, that we have got till now, and we'll compare it. To my sum. Okay. Basically, so basically, what I'll do is, suppose, as you are given with this, this is what the sum I got. 36, right? So s is equal to 36. My final sum is 36. My z is 36. Okay, my z is 36. What I can do is, now I know these. Like if I just traverse, I know this x, I know this z. So what I can do is, I can compute my y. And I can just compare this y equal to x, okay. Basically if this is my x, suppose basically this is my x and this is my y, this is my z. So if I just subtract x from z from a, basically x from z, what I'll get is, I'll get the y, and at each step if I compare my x and my y, if they are equal, I'll simply return true. Basically not true, my index, by my current index, or I'll return false, or I will return false. Okay, I'll just do the dry run and tell you, so that you get a more clear understanding. Just remember that in the first case, in the first part, both of these numbers, both the first and the last numbers are included, and the second part also, first and the last numbers are included. Okay, so this number would be overlapping, this middle number would be overlapping. Basically if this is my case and these are my values, this is my first case, so this will be my second case. Okay, so this value would be overlapping, so this you have to just take care of it. Okay, I'll just try to take the test case where n is equal to 8. So it becomes like 1, then 2, 3, 4, 5, 6, 7, and then 8. Okay, this is my test cases. As I got my z as 36, the z at 36. Okay, now I have my x here. What I'll do is, I will not get it. I'll not, like, if I suppose this is my sum, too, that is currently 0. Okay, and or this is my x, value is 0. Okay, suppose if I first incremented, okay, x would become 1, because 0 plus 1 would become 1. Okay, and then I try to subtract, so 36 minus 1 would be 35. But that is only the sum of these numbers, Okay, but what I want to get, I want to get the sum till this. Okay, and for the first test case, and for the first part, my sum is to be till here. Okay, basically, if my x is still here, my first part would be like this, and the second part should be like this whole array. Okay, this whole array. So these will be my two arrays, the first part and the second part. Okay, first part and the second part. This is my first part and this is my second part of the array. Okay, so while traversing, first I have to get the difference. First I have to get the difference between z and x, so I'll get a value y. Okay, then I have to add this index value, add the current index value, and then I'll have to compare. Then I'll have to compare so that it gets added in both of these array. It gets added in both of these array. Okay, so x plus equal to 1, so x would become 1, and in this case y is equal to 36. Y is equal to 36, so they are not equal. My x would increase. Okay, I'll just try to show you. Okay, I'll try to erase it all. Just remember my z value status. I'll just write it smaller only because it's taking up a lot of space. Okay, 1 2 3 4 6 7 8. Okay, 1 2 3 4 5 6 7 8. Okay, so what I'll do is, I know my z value. My z value is fixed. It's not gonna change. Okay, but when my x is here, okay, first what I'll do is, I'll just subtract it from my x value is currently 0. My x value is currently 0. I'll subtract it. So what I'll get is my y value. Basically, what I'm doing is z minus x, that is equal to my y. That will be equal to my y. So I got the y value. Okay, and what I'll do is I'll just increment my x. My x would become 1. I'll compare both of these. So x equal to y, 1 equal to 36. Is this equal? No. So my x would increase. My x would come here. My x pointer would come here. Okay, now my z is fixed. But what I'll do is I'll first get the difference. So what I'll get is, I'll get 35. Okay, this is my y, and now I'll add this. Index value. So 1 plus 2 becomes 3. So what I'll do is, for the second pass, I'll just compare 3 equal to 35. Is this equal? No. My x value would increase. My x would come here. Okay, x would come here. First, what I'll do is I'll just get my sum. I'll just get my value difference. Okay, so it becomes 36 minus 3. That becomes 33. This is my y value. Now I'll add it to my x also. So 3 plus 3 is equal to 6. X is 6 for my third case. X is 6. It is equal to 33. Is it equal? No. Is it equal? No. So my x value would increase. X would come here. Okay, so I'll first get the difference. Okay, I'll first get the difference. 36 minus the current value 6, so it becomes 30. And is it equal? To my x? No, it is not equal. So what I'll do is I'll just increment my value. Okay, this becomes y, and I'll just add it. So it becomes 6 plus 4 is equal to 10. Okay, are they equal? 4, 10 equal to 30? No. Okay, for my fifth case, my x value increases. X comes here. My current difference is calculated. So 36 minus 10 is equal to 26. Okay, and this value is then added. So 10 plus 5 is equal to 15. Is 15 equal to 26? No, it is not equal. So okay, my pointer would increase. Pointer would come here. So now what would it will become? 36 minus 15. 36 minus 15. That becomes 21. That is my y, and what I have to compare? Y with x, because x is the first part, y is the second part, and both of these parts should be equal. Okay, so I'll just add my 6 to this. It becomes 21. So is 21 equal to 21? Yes. So this is the part this is the index which would be returned. So if I get the index of the current number, okay, so this is 5 and 5 would be returned for this case. 5 would be returned for this case. This is my pivot index. This is my pivot index. I did nothing. I just did nothing. What I did is basically just got the sum for the whole array and just broken it down into two parts, where this is z, x and y. I know that x plus y is equal to z, so y is equal to z minus x. Okay, this I now I have y, and as I'm traversing I have x, so I can just compare this x and y values. Whenever they come equal, I'll just return my pivot index, and if it never becomes equal, I'll return -1 at last. I'll return -1 at last. This is my overall solution. As you can see, it is a very intuitive solution. Okay, if I just try one more test case for non-existing, okay, n is equal to 4, n is equal to 4. So my numbers would be like 1, 2, 3 and 4. Okay, first step is to get the sum of all these numbers. So 1 plus 2 plus 3 plus 4, or 4 into 5 by 2. So it becomes 10. Okay, so sum is 10. So my z value is 10. Now at each step, what I have to calculate? I have to calculate z minus x, but before including the current index. So if my x is here, currently x is equal to 0, I'll just get my value. So 10 minus 0 is equal to 10. Okay, and just add this. So 0 plus 1 is equal to 1. Now what I'll do is 1 equal to 10? 1 equal to 10? No. Okay. I'll just move a step forward. My x comes here. Okay. So what it becomes? 10 minus 1. 10 minus 1 is equal to 9. Is okay, and this x is also added. So 3 equal to 9? 3 equal to 9? No. Okay, my x value is increased. My x comes here. Okay, x comes here. I'll get the difference with this x value. So 10 minus 3 is equal to 7. Okay, and I'll add it to my value. 3 plus 3 is equal to 6. So is 6 equal to 7? No. Okay, I'll just increase my x value. My x comes here. I'll just get the sum again. I'll just get the y value again. Okay, what is my y value? 10 minus current is x value, so 10 minus 6, 4, and I'll just add this value. So 6 plus 4 is equal to 10. So is 10 equal to 6? No. Okay, and I have reached the end of the array. So in this case, my answer would be -1. It's a very simple approach. Okay, if I just try to code it down, what I need is I'll need one sum. Okay, and I'll have to add it to all the numbers, because basically I'm including the first and the last number. So I'll start from 1 and end till n. Okay, I'll just add all the numbers. I'll take z for your convenience, because I've just told you in z form. Okay, I'll take my x equal to 0. And for every value, I'll calculate my y in advance, and then I'll just increment my x, and then I'll compare my x and y. If it becomes equal, I'll return -1. I'll return my index, else I'll return -1. If I try to run it, if any error occurs, we'll just solve it together. Okay, no, okay, I just try to submit. Okay, submitted successfully. 100% users. Yes, nice. Okay, so if I just want to summarize what I did, basically I just splitted the whole array into x and y parts, and that is equal to total z. So I'll get an equation that x plus y equals to z. So this I can get is y is equal to z minus x. So now I know my y as well as my x. So I'll just compare x and y. If they come equal at any point, I'll just return my pivot index. Else at end, I will return -1. So this is for getting the sum. This is for getting the z value, and this is my x value. I'll just iterate. I'll get the y value. I'll compare x and y, and this I'll return. If I just try to analyze the time complexity, first loop takes O of n, this loop takes O of n at the starting loop, this loop takes O of n. Okay, what about the second loop? Second loop also takes O of n. What is my time complexity? My time complexity overall becomes O of n. Okay, time complexity becomes O of n. And what is my space complexity? Am I using an extra space? No, no. So what is my space complexity? O of 1. Okay, so my time complexity is O of n and my space complexity is O of 1. So this was the overall solution to the question. Find the pivot integer. We have just read the solution. We have read the basically question. Read the question. We moved on to the solution. We just discussed what the question wants us to do and how we can approach this. Okay. If you like the solution, if you have any doubts, you can just ping it down in the comments. And if you like the solution, do like, share, subscribe. Thank you. Have a nice day. Bye bye.